Okay, so let's look at the atmosphere. Now, that's part one of the book, or the atmosphere, the energy atmosphere system. The atmosphere is just this thin veil of gases that surround the Earth. Its main purpose is to form a protective boundary between outer space and the biosphere. You can read about all this in the book, about 300 miles up and so forth. The hydrosphere, which is part two of the book, is the water, the weather, and the climate systems. Again, it's an open system that contains all the Earth's water. The input might be rain, the output is evaporation, for example. And there's three stages: liquid, solid, and gas. You should know that by now. Again, the next important thing I want you to remember is this: water has very important heat storage properties. It can store massive amounts of heat. And remember, it moves, and so when it does, it takes that heat with it, whether it be in the oceans or in the atmosphere. Okay, so just keep that in mind for the rest of the semester. It's also a great solvent, an extraordinary solvent. So when we get to, I think it's chapter 11 on rivers and so forth, we'll get into that a little bit more. So it's very important to shaping the Earth's surface. Part 3 is the lithosphere, where the atmosphere touches the actual Earth, so it includes the Earth's crust and the portion that's directly underneath us, down to about 45 miles. Importantly, it contains all the Earth's soil. So that's part 3. We'll be talking about tectonic plates and earthquakes and volcanoes, the coastal systems, glaciers, karst, which is like caves and so forth, and weathering, things like that. And then the soils is actually in part 4 in the biosphere, but that's a lithosphere. Okay, and then part 4 is the biosphere, which is different editions of the book have different chapters. So when we get to that point, I'll go over that in a little bit more detail, okay? Now, make sure you know this in the book about the Earth's dimensions. Know that we're bigger at the equator, or than the distance around the equator is distance than the circumference around the poles by about 47 miles. And that's because the Earth rotates on its axis, and which we'll get to next chapter. But again, just be aware of that, okay? Make sure you know about latitude and longitude. Two very important concepts, because it allows us to give an absolute location it's a point for anything on the surface of the Earth. And time is related to that, which I'll show you in a second. So latitude is just angular distance north or south of the equator. So here's the equator at 0, so you can be angular distance north, you can be angular distance south. So you're measuring from, here's the equator, you draw a line out there in the center of the Earth, and then to wherever you want on the surface. Here they're saying the 49th parallel. So that angle is 49 degrees, so your latitude is 49 degrees. Lines that connect points of equal latitude are called parallels. So it's parallels of latitude. Equator is 0, North Pole is 90. Okay, so again, know that, burn that into your brain. Angular distance north or south of the equator, a line connecting all points of the same latitude is a parallel. The equator is 0, and the poles are at 90 degrees north and south. Since we are in the northern hemisphere, we're going to spend a little more time talking about things in the north as opposed to the south. So kind of keep that in mind too as we go along. Latitude you can easily determine by just, finding a fixed point. At noon you go out and see where the sun is, and the angular distance between the horizon, which is 0, and the sun, that will give you latitude. At night, the horizon, and just find the North Star, and that will also tell you, Polaris, the North Star, it's in the handle of the Little Dipper. That will also tell you the latitude, your latitude. Latitude was really easy to figure out. So, even back in the days of exploration in the 14th and 15th century, sailors pretty much knew their latitude, and that enabled them to find the winds that would bring them to the New World and then send them back to Europe, which we'll discuss in later chapters. This is in the book, so make sure you are familiar with this graphic. It's a latitudinal zone, so know these names and where they are. Okay, really, really, really important. Know the latitude of the Tropic of Cancer, the equator, Tropic of Capricorn, 23.5 north, 23.5 south, and 0. That area in between is what we call the equatorial and tropical. Anything right above it is subtropical. The mid-latitudes where we live, 35 to 55, subarctic right below the Arctic Circle, and then the Arctic is above the Arctic Circle into the North Pole. Now, these two tropics are really important. We'll learn that next chapter, okay? But again, I can't overemphasize. Make sure, at least for the northern hemisphere, know these degrees and know these names. Longitude is angular distance east or west of what we call the prime meridian, the north-south equator, if you will. It was settled by treaty in 1884 at the Berlin Conference, which had to do with the colonization of Africa. The countries didn't want a war over it in Europe, so they just divided up Africa. But they needed to, up until that time, every country had its own prime meridian. This standardized it. So now you had an equator east to west and an equator north to south. The British were the most powerful nation, so that ran through Greenwich, which is the location of the Royal Observatory. So that's 0. So your angular distance west or east of that prime meridian. So it's 0 to 180 degrees east, and 0 to 180 degrees west. Okay, angular distance east or west of the prime meridian. Lines connecting all points of longitude are meridians. So parallels of latitude, meridians of longitude. Make sure you remember that. It's on the test numerous times. Again, the prime meridian was just arbitrary. It was just settled by treaty, and all longitudes are measured east or west of that from Greenwich, England. It's an interesting story. Don't really have time to go into it today, but you can find articles about it, or just find the wiki page on it, and it'll tell you all about how the prime meridian was invented, and also the story of how it was measured was also pretty interesting as well, because even though longitude was easy to figure out, latitude was easy to figure out, longitude was a little more difficult, and there was a big prize offered, 20,000 pounds, anybody could figure out how to do it, and which, back in the late early 1700s, and that was like $20 million by today's money, so that in itself was pretty interesting story. Importantly, too, because this has to do with map projections, is that latitudes, no matter where you are on the surface of the Earth, they're generally the distance between the latitude degree length is about the same. It varies just a little. However, longitude is a little different, because the arc is 1 degree here, but it is 1 degree here, but by the time you get to the North Pole, it's 0. So the distance here is greater between meridians than it is at the pole. And you can see this here, 0 at the pole, about 111 miles at the equator. Now, this is important when you want to make a representation of the Earth as a map. Well, how do you, if you draw a straight line straight up, you get this blank space here. What do you do with that? And I'll show you that in a couple slides. So just, again, distance between degrees of longitude is about the same, but distance between degrees of longitude decreases as you get closer to the pole. So distance between latitude is about the same, Distance between degrees of longitude decreases as you get closer to the pole. So parallels connect points of equal latitude. Meridians connect points of equal longitude. Again, make sure you remember that, along with water being a great, can store a great amount of heat. That's just another way to look at it. We're, kind of about at 34 north and 118 west. It's actually Oxnard. Oh, it is Oxnard, yeah. That's about the degrees of the point where Oxnard is. So that's your meridians. Now, meridians are also related to time. Well, you know what? Let's take a break. So I'll end part 2 here, and this will start part 3.